they will migrate.
Mm-hmm.
The negative will go towards one pole, and under the same conditions, they will align it towards the other one.
Mm-hmm.
So the positive thinkers will separate out, and the negative thinkers will think. But the Munafiq is likely to remain his position both ways.
Okay.
He is a hypocrite. He is both positive and negative. Wants to take advantage of the positive as well as negative. He is nowhere.
So you're saying Munafiq is like a half Muslim?
Yes.
Hypocrite.
Hypocrite. But can you give me, in words, he's
Not half Muslim.
Okay.
He's thinking something else and doing something else.
So give me an example.
People who are showing off their allegiance to someone, but in actuality they are not with them.
Okay.
That's the perfect example of Munafiq.
Okay.
So there was, in the historic perspective, these were the people who were pretending to be with the Prophet, and they weren't actually with the Prophet.
Okay. I get it. This one's good here. You've got page 120.
So boss, Libb,
Yeah.
the significance actually is really, from the social perspective, the significance is there. A lot of significance is there. If you have these kind of people, no change can happen.
Yeah.
They will keep pretending that they are with you. They are going to actually keep causing problems.
Mm-hmm.
So the issue is that the energy that the leaders exert on the change, it's not going to happen. It's not going to reach the results.
Okay.
Yeah.
I see what you're saying.
Yeah.
So let's say what you have here. This is a good quote from this chapter. You say, if the lures of worldly affairs are considered
having a motivating force, potential, similar to the electric field, the non-polar nature assigned to the Sahabi or to a Muslim would not be affected by it.
Yeah. So I like this way.
On the contrary, a Munafiq, because of his polar nature, would easily orient himself to motivating force potential of the wealth and or evil forces, thus creating a split between mind and mind.
So here you're saying that
You see, it is the motivating force. He finds advantage in following the rules of the law. He does not find any advantage. He is malleable. He can go anywhere.
Yeah.
But he will always go towards his own gain.
Okay.
He doesn't care about the rule of law.
Let me give one point of view.
Yeah.
When you're asking me about a lot of the Pakistani culture has a lot of potential, but not a realization of potential.
That's the case. Yes.
Okay, so here, according to Mirza, the motivating force potential, he says wealth is evil. So if you're telling, according to the
wealth or evil, wealth and evil,
and or evil force.
Yes.
So what is the evil force?
It can be anything. It can be power. It can be. See, power can be used for negative purposes. Power can be used for positive purposes.
Mm-hmm.
These people mean personal benefit, and that can be used. Absolute power corrupts absolutely, right? That's what. So absolute wealth, absolute power, they try to actually achieve. So you are absolutely right. This case actually relates to us in Pakistan. That's the issue. Their mind is somewhere else and their body is somewhere else.
Mm-hmm.
A hypocrite is a malleable substance, let's say.
Now we're getting somewhere. Now we're up to chapter 7. You want to take lunch prayer break before we get into this, or you want to keep going?
Let's if it is
the end of the chapter.
You want to go back to the end?
Yeah.
Okay. You tell me where.
Because there is a lot that has been said. This is where I was criticized heavily. I drew a scale. Yeah. This is what I tried to do.
Munafiqat scale?
Yeah, hypocrisy scale.
You said you were criticized by someone?
Yes, heavily.
I was criticized for having developed a scale of this kind. Go ahead. What a mess.
Yeah.
You may be right.
Yeah, see, the thing about this is,
These are the parameters.
yeah,
These are the parameters of the scale.
Come on, it's a
It is
1986 book.
beyond known means of income. Offers loan with strings attached. Moral integrity is doubtful. Gets involved in backbiting and eavesdropping. Practicing religion only nominally. Is a non-conformist to the norms of the society. Seeks diversity and polarization. Answers and discourse in parentheses may range from 0 to 3 and 10. And that gives a scale
Yeah.
as to how, what will be the munafiq, or
Yeah.
what will be the amount of munafiq
Yeah.
in that society. And then I assigned a few numbers
yeah,
and found that the Arabs are just as much hypocrite as anybody else, and the society is full of economy. Our ills are because of hypocrisy, not anything else.
Let me put this in perspective.
Yeah.
Let me put this in perspective. If you're so much against the American society, why do you migrate? I mean, you go over there and try to actually establish your own little
Yeah.
circle
Yeah.
in which you are trying to actually. There are other places you can go. Why are you migrating to USA?
yeah,
The main problem is that these people are munafiq in their own nature.
yeah,
They are going over there and they are trying to create some havoc. So from 0 or 1 to 10, you will find these people in their reality that they have in their mind. All right.
yeah.
So this one, the person who's the least required person over there, this person would be a terrorist.
Okay. Well, let's move forward because this is one of the weaker chapters of your book.
Yeah.
Let me explain.
I've been elaborating on that.
Well, the
There are
reason
two
is.
papers already that I have published.
Okay, well, let me just explain why it's weak. Because the theory you're using here is called the human particle model. And you're saying that a person has a positive and negative charge. So you're modeling a person to a pretty much a hydrogen atom, and it's just governed by the direction at which the electric field motivates their line. So that's a simple model, and there's lots of people that have done those models historically, and they're not necessarily based on universal principles, because the first and second law of thermodynamics, which produces the Gibbs free energy, that's a universal principle. So it's guaranteed that what you're saying is it has to be true. But what you're saying here is not the positive and negative charge model of a human. That's not guaranteed to be true. It's just more like an analogy. So when you're getting into these points here, these are just your own
Can you please
opinions.
suggest where we can actually improve?
We'll just reduce, spend more time on the Gibbs free energy, because that's guaranteed. Because it's guaranteed that the first law of thermodynamics applies to the society, applies to every system in the universe. It's guaranteed that the second law of thermodynamics, the entropy, applies to every system in the universe. And when you add the entropy, the energy and the entropy together, you get the potential for the isothermal, isobaric systems. It's not the Helmholtz free energy, which you correctly said, it's the Gibbs free energy. And very few people talk about that. A lot of people talk about this. All of this is just your own opinion. It's not based on any measurement. Like when you say, pick any point. I practices religion only nominally. That's just it's not, that's just your own opinion. It's not based on any kind of measurement.
So I get what you're saying.
So we only have 3 hours left. So we want to go to the next chapter.
It can only be qualitative. I agree.
Yeah.
It can. This scale is only.
Yeah, we can come back.
To a better scale.
Dr. Beg, we'll improve on that.
Yeah.
We'll improve on that on the second
Yeah.
edition.
We want to go camel. We want to ride the camels today at 4. We can talk about Munifakat, but the camel riding we have to get. I've only come to Pakistan. My first time here, I have to ride the camels.
The camel ride because it goes like
Yeah. So right now we're getting into these are good guides right here. Decline.
Okay.
Now this, nobody's going to argue with you about this. If you say that the system where there are just a decline of societies and entropy, everybody in the world is going to agree that entropy change, the increase in entropy is behind the driving force of changes in society. Everybody is going to agree with you. They won't. If you start with this, it's let me show you an important quote here. This is called the
So
it's
this
called
is
the
the point of
Eddington.
commonality.
Yeah, this is the starting point. You can,
Yeah.
if you start here, it's
If
called
we-
the Eddington rule. Let me show you here.
So we can change the chapter, like to the beginning or something. The beginning of a section,
Yeah.
maybe. I'm thinking in those directions actually.
So see how I type Eddington rule, eoht.info. Now, if you start out with this here. This is pretty much summarizes what you're talking about, entropy and decline of. Eddington says, if your theory does not conform to the second law of thermodynamics, you will collapse in deepest humiliation. So here he says, the law that entropy always increases holds, I think, the supreme position among the laws of nature. If someone points out to you that your pet theory, so the last chapter about Munifakat, that's pet theory. It's not based on, it's like your own little idea. So Munifakat, based on the poles in the battery, that's a pet theory. It's interesting, but it's just like you're comparing a person, the hydrogen atom with a positive charge. So he says if your pet theories of the universe is in disagreement with Maxwell's equations, so much for Maxwell's equations. But then he says, if your pet theory is found to be contradicted by observation, well, those experimentalists do bungle things a bit. But if your pet theory is found to be against the second law of thermodynamics, I give you no hope. Where he says, there is nothing for it but to collapse into deepest humiliation. So you might be humiliated by the Munifakat chapter because it's kind of a loose, it's an interesting idea, but you can.
Well, we can actually I think it's not substantiated with enough facts. That's the
Okay,
only
so
thing.
let's go back to this chapter is more
Yeah.
powerful. Well, now we're talking about the decline of civilization. So now you say the specific reaction rate is the amount of matter transformed per unit of time. Okay, so that's good here. Well, now we're going to get to this here. The driving force delta F. The F got switched over historically to get everybody on the page. It got switched over to G in 1923, but in some publications they used to call it the Gibbs free energy F because it was based on the German word I think free energy or something like that. But then Gilbert Lewis named it in honor of Gibbs, the Gibbs free energy in 1923. So the symbol he's using here is delta F. After 1923 became delta G. So he says the driving force delta F of a reaction is composed of two terms, namely the enthalpy change or the heat content, the heat of the reaction, and T delta S, the increase in the entropy or randomness times the temperature of the nature. Now, entropy could be the measure of randomness, but this needs a little more work. It's more of an order of the organizational content of the order of the molecule. And so we can measure the entropy, and we have what's called entropy tables. So let me just show how this works real fast. These are called free energy tables.
You have your own search engine, right? You have your own search engine.
I have my own search engine, but it doesn't work that good because the code, the person who does the programming, every 10 years the internet advances, so they have to redo all the code. So the coding for the search engine doesn't work very well. So it's better to use Google. You just use Google search engine, whatever term you want to work, and then comma UHT, and you can find what you want. Because this is you see there here, this is the internal search engine, right there. But if it doesn't work so good, it'll give you some terms, but it's not up to date. So here we're talking about, you say the entropy is randomness, so we're going to give a little introduction. So here's the affinity table. So affinity table shows the chemical forces, how they work. These are reactant 1, and these are possible reactant 2s here. Now these got historically changed into free energy tables. So what they found was that this is the Helmholtz free energy, and this is, let's see, so affinity tables got changed into free energy tables. That's what they're right here. Now we're going to look at those to explain how entropy is. So now, when you said entropy is a measure of randomness, that's not completely true here. So now we have different species. So now we have acetic acid. We can measure all of these. Yeah, it has an entropy of 159 kilojoules per mole, and compared to acetaldehyde has a measure of 264 kilojoules per mole. So it's not specifically a measure of randomness. So entropy has a certain order to it, and supposedly, according to the way we have it, entropies at absolute zero are supposed to be perfectly ordered. So the lower the entropy, the more ordered the structure is. So at absolute zero of temperature, all crystalline substances have perfect order. They're supposed to be perfectly ordered structures and have zero entropy. So the higher entropy you get tends to be more complex or more gaseous-like substance. And then we can measure the enthalpy for each species and the Gibbs free energy for each species. So we can organize these down into human species, and we get what's called the human free energy table. So these were the original. Gilbert Lewis was the one who invented the concept of free energy table. This was 1923. He started calculating the free energies of different substances, hydrogen, lithium, and so on. And from these measurements, we were able to calculate how much free energy it took to form a human or to form a bigger molecule. So he's got all the different free energies here. And then now, here's the first table of free energies of biochemical substances.
So this is created by you?
No, this is done in 1957.
Okay, Burton.
Keith Burton calculated and measuring your free energies of living matter. He calculated free energies of 100 biochemical species. So at this point, we're getting the idea that we can measure what you would call living molecules, but now we call them just powered molecules.
Active, powered.
Yeah, powered. So now we have, these are molecules, free energies of biochemical species. So he's got these listed here. And now, so this comes from, to create a rabbit out of nothing and place it on the table, the magician, or the universe in this case, or you would say Allah in this case, need not summon up the entire enthalpy, H equals U plus PV, some energy equal to TS can flow in spontaneously as heat that's over here. The magician, or as I say, the universe or nature, or as you would say, the Allah, must provide only the difference, that is G equals H minus TS. And so Big thinks this is the free energy is the will of Allah, but we all have a different perspective. But this comes from Gerald Schroeder's 2000 thermal physics book. So this is the modern view of the formation of something like a rabbit or a molecule or a human. It has a certain free energy to form it. So that's why we restart your web page. This is the starting point. If you say that it takes a certain free energy to form a rabbit, you can cite Gerald Schroeder, you can cite me, or you can. Now, if you want to branch off and say like Mirza does it, that it's the will of Allah, then that's one point of view. You can use that, and I'll say it's just the energy of nature. But but the point here, when I brought when you said entropy is a measure of randomness, you have to be careful because the first person to break off from that view is Norman Doloff, and he said you can start measuring these, make these tables, like the table of biochemical species, and then you get what's called human free energy tables. I'm going to show you.
That's what I'm actually looking forward to look at.
So now we've got, these are free energy formation of biochemical species. Now we've got human free energy tables right here. So now, human free energy table. So now, the extrapolation of this is that for each person, we have, this is a mock table made up by me. So instead of, because we can't, scientifically, it's very difficult to, there's a whole subject matter of calculating human enthalpies and human entropies. You can look those up, but here is, let's say this was Mirza, and this is the Gibbs free energy of Mirza is negative 398 kilojoules per H mole. And the free energy formula for Faison is negative 169 kilojoules. So the negative signs mean you are spontaneously formed, your mother and your father were collided in the universe, and they collided, and their collision energy got you over the activation energy barrier to form you as a product. So you're naturally favored, unless it was a forced marriage. So some children are formed, even though, for example, Sophia, she has a molecular formula, which is a 26-element molecular formula, but because her free energy change is positive, that means that the marriage normally wouldn't go on the own, but sometimes the family can arrange the marriage and make the reaction happen, and Sophia can come into existence. So the point here is when you say that entropy is a measure of randomness, you have to be careful, because Norman Doloff was the first person who started making this kind of idea that you can put people on a scale like this. You can calculate the entropies of different people in different states, and then you can add the entropies plus the enthalpy measurements to measure the free energy. So it's not simply a matter of saying entropy is just a measure of randomness. So
these are hypothetical figures.
Huh?
How did you come about?
These are random.
How have they come about these figures?
Okay, so these are
or assigned?
not real.
No, this is
hypothetical.
Hypothetical figures, but you can type in, for example, let's say Emma has an enthalpy of, more work has been done in entropy, so watch, I'll show you. If you type in human entropy.eoht.info.
Sir, I do understand the word entropy, but I don't have any knowledge about enthalpy.
Okay, watch, human enthalpy. Human enthalpy, EOHT.info. So now it becomes human enthalpy, and you can look at the history of the whole subject. And you can see so Mirza, in your book, you're talking about human enthalpy. But historically, in 1984, Hungarian physicist Bela Lucas, citing the previous work of Bela Lucas.
Can I have a look at the table, please?
This comes from the book, my human chemistry book. This is from the chapter.
Groundbreaking. Absolutely fantastic.
Yeah. So this divides human enthalpy in terms of.
So basically, all these factors have an impact on what you're calling enthalpy.
Yeah. So Mirza's got it in his book. He has the delta H. It's in. We're coming up to it right now.
This is what we call potential.
Yeah. So this is Mirza. If you look at Mirza's book, page 135, he's got the enthalpy right there.
Right.
But he doesn't. He knows that it's knows that it's important.
Yeah.
But he doesn't. So Mirza. Let's see. So James Reese in 1994.
So how do you, in simpler terms, can you give me a definition of enthalpy?
It's heat content. It's simple terms I'll give you.
Is it
Okay, watch.
is it how potentially
No, watch.
reactant is it?
Watch. There's the word right there. I'm going to click on it. Enthalpy formulaically is okay. So formulaically, it's the
defined as the sum of internal energy.
So
Yes,
sum of
potential.
internal energy.
Yes, potential. Okay.
It's the sum of the internal energy of the thermodynamic system plus the energy associated by the system, the pressure volume work. So this right here, so the internal energy is the sum of the
What's U?
Field energy plus PV.
So first we have to start, it's a little bit complicated, but you have to read through Rudolf Clausius' book to understand it, but internal energy is the sum of the, this is the
This is H for
kinetic plus potential energy. So,
kinetic plus potential energy.
okay, so in any system, so let's say this is the three of us as our system, okay? The H is the Ergol. Okay, J is the Ergol, and
H is an enthalpy, isn't it?
okay, H is the quantity of heat actually existing in the body, the vis viva. So H is the kinetic energy. Vis viva means living force in Latin. So you see how this is another example where I'm saying you have to be careful of using words like living.
I am only taking the abstract. Don't
Okay.
worry. I'm
Okay.
going to actually read it again.
Well,
Just hold.
let me give you. This is one thing we've learned from history.
Yeah.
So before 1850, we would call the equation energy equals 1/2 mv squared, the kinetic energy. All the people like Newton and Leibniz, they would call it Latin for living force.
Yeah.
But now they got to the point where they threw that term out the window, and they was living force. What does that mean? Living force. So they switched over and they called it kinetic energy.
Okay.
That was a change that happened in the scientific community. So this H, the internal energy, is the H is the amount of kinetic energy in the system. So it's the motion of the three of us.
Right.
The mass times the velocity. Right now we're sitting, so we have low kinetic energy, and it's the mass. There are three masses times the velocity. Our velocity squared divided by 2. So that's what this is.
So you know where I am actually, where my mind is going right now.
Yeah.
I'm sitting with two scientists